Hey guys, good morning to everybody. Hopefully, everybody had a good weekend. We're into, I think, the third to last week of school, so getting there. I would like to encourage you to just finish strong and continue to reach out if you have any questions. Last week we talked about arithmetic sequences, which are basically linear. Today we're going to start talking about geometric sequences, which are not linear. All right, so on that note, I'll read the learning target and then we'll get to it. Learning target states that I can produce the formula to describe a geometric sequence, and I can use that formula to find the nth terms of a geometric sequence. All right, so then it states a definition here. I'll kind of skip over that, but here's an example of one. A sub 1 is 4. We know what that means. And then the common ratio. So remember with arithmetic sequences, we had D for common difference. Here we have R for that common ratio. And so if this were an arithmetic sequence, we would take 12 minus 4 to get plus 8. But then obviously 36 minus 12 is not plus 8. So anyways, the difference here is that you divide. 12 over 4 gives me 3, just like 36 over 12 gives me 3, and then 108 over 36 is going to give me 3. So anyways, that's how you find that common ratio. And from that, we can do a lot with those two numbers. So that gets us to this next. Example 1 says, is the sequence a geometric sequence? If so, state what R is. So here we're going to say 12 over 3 is 4, and 48 over 12 is 4. So that would be a yes, where R equals 4. I'm going to skip around, skip to C. Here, 6 over 3 would be 2. 9 over 6 would be 3 over 2, or 1.5. So the answer here would be no. What type of sequence is that, though? Arithmetic. Skip D, go to E. So here we'd have negative 8 over 4 is negative 2. 4 over negative 2 is negative 2. And then negative 2 over 1 is negative 2. So looks good. We would say yes here. And R is negative 2. So anytime you have a geometric sequence where R is negative, you're going to see that positive negative pattern. Okay. Next one, a little bit trickier, but remember you can always use your calculator to kind of go a little bit quicker there. So what would 1 over 27 divided by 1 over 81 be? It's going to be 3. And then we would do 1 over 9 divided by 1 over 27. And that's going to be 3. I'm not going to write that out because I just showed it, but we will say yes, where R equals 3. All right, so next example says find the next 3 terms of the geometric sequence. So here we just assume it is geometric. We don't need to check. So find the next 3 terms. We do need to figure out what R is. So 30 over 15 is 2. So 60 times 2 is going to be 120. 120 times 2 is going to be 240. Double that, and you get 480. Next one, what can you tell? Because you have that alternating pattern. R is negative. All right, so negative what? 120 over 30 is going to be 4. 30 over 7.5 is 4. So negative 4. So, sorry, that's not right. So if we're decreasing an absolute value, that tells you that it's going to be a fraction. So I would have divided backwards there. Sorry, I was doing 120 over 30. So it should be 30 over 120 and then 7.5 over 30. So 30 over 120 is 0.25, which is equal to 1/4. So R is negative 1/4. Okay, so I caught that mistake because I could tell that my numbers were decreasing in absolute value, so it wouldn't make sense that R would have an absolute value bigger than 1. Anyways, negative 7.5 times negative 1/4 is going to be 1.9. Punch that in. So negative 1.875, or sorry, positive 1.875 times 0.25. Sorry, it should be negative 2.25. Must have typed it in wrong. 1.875 times negative 0.25. And I think on the notes I rounded to the nearest tenth on these, so just pay attention to what the rounding directions say on MathXL. So you don't write out these ridiculous decimals like I'm doing. 1171875. Like I said on the notes, I think I just rounded to the nearest tenth. But do pay attention to that pattern, positive versus negative. All right, so now we get to I think the main part of the lesson, really. So what if I asked you to find the eighth term? Well, just like with an arithmetic sequence, we could take the recursive approach, which would just be to say, okay, so a sub n is just equal to a sub n minus 1, which is the term before, times r, which is the common ratio, or explicit. So on the next page, we'll see this formula that a sub n is equal to a sub 1 times r to the n minus 1. So that's the formula right there that will find you any term, such as the eighth term. So we're going to be using that a lot on this page. So getting into example 3, I'm going to skip A because obviously I've made a formatting error here, but you can see that formula. So anyways, we'll use it on B and C. All right, so looking at this one, we can tell that R equals 3 and A sub 1 equals 4. All right, so then my formula would be a sub n equals 4 times 3 to the n minus 1. And then we're asked to find the 10th term. So a sub 10 would equal 4 times 3 to the 10 minus 1. Or just type, sorry, n minus 1. It's like a 9 in my head. So here's how I would type that in. 4 times 3 to the power of 9, just so you don't forget parentheses or something. So that is going to be 78,732. Obviously talking about exponential kind of growth curves here. Next one, we can tell that R is negative. We have that alternating positive negative pattern. So R in this case is going to be, what's 18 over 36? That'd be 0.5 or 1/2. So anyways, a sub 1 is negative 36 and R is negative 1/2. So my explicit formula is a sub n equals negative 36 times R, or sorry, times, we know R, times negative 1/2 to the power of n minus 1. And so a sub 7 can be negative 36 times negative 1/2 to the 7 minus 1, so I'm just going to write to the 6th. And remember, parentheses are important when you have that negative base. So negative 36 times negative 1/2 to the power of 6. Good question. Before I punch that in, is my answer going to be positive or negative? Can you tell? So it's going to be negative because that's going to be positive, and then I take that times a negative. Anyways, it's negative 0.5625. And just pay attention, like I said, to rounding directions on Math Excel and stuff. All right, so moving on, example 4. All we're doing is writing the formula here, which is nothing really different than what we've been doing up there. So just practice on that a little bit more. So here, 6 over 2 is 3, 18 over 6 is 3. So R is 3, A sub 1 is 2. So formula A sub n equals 2 times R, keep doing that, times 3 to the n minus 1. Let me write that again. A sub n equals 2 times 3 to the n minus 1. And then the next one, 2 over 10 is equal to 0.2 or 1/5. If you did have to do 0.4 over 2 to come up with that, you could make it equal to 4 over 20 and reduce, or you could just divide and then use your calculator to do the fraction feature. Anyways, that's R, and A sub 1 is 10. So my formula, A sub n equals 10 times 1/5 to the n minus 1. All right, and I guess just important to use parentheses anytime you have a fraction exponential base as well. All right, so these next ones are kind of just a little bit tricky. Not too bad, but got to use a little bit of algebra to maybe figure them out. So let's do it. So here we know A sub 1 is 2, and we know A sub 2, A sub 3, A sub 4 is negative 54. And now we're basically going to use our formula up here to figure out what R is. So we're going to solve for R. So let's see how we can set that up. So we're going to say basically A sub 4 is equal to A sub 1 times R to the power of 4 minus 1. So now we're going to sub in. We know what a couple of these are. So this would be negative 54. We know A sub 1 is 2. We don't know R. So how could we solve for R in this case? Well, we're going to divide both sides by 2 and then take the cube root. So divide by 2 gives me negative 27 equals R cubed. Then the cube root. is going to be -3. I guess I can show as a reminder how to punch that in. Cube root or any root is going to be under your math function. So, so if you hit math, there's cube root. Any higher root, you'd use the x root function where you type the root in first. So anyways, cube root of -27 is -3. All right, so now that we know that, we're just multiplying by -3 to get to the next term. So 2 times -3 is -6 times -3 is +18, and you can see that 18 times -3 is -54, so you know we're right. Go a little bit quicker on the next one. So it's very similar. A sub 1 is 9. A sub 2, 3, 4, 5 is 144. So I'm going to skip that first step here, and we're just going to sub in a sub 5, which is 144, equals a sub 1, which is 9, times r to the, that'd be 5 minus 1 to get 4. So here we're going to have to take the fourth root. So go ahead and type all that in for you. So 144 over 9 is 16. Then you probably know the fourth root of that is 2, but I'll show it anyways. So 4 math x root. So fourth root of 16 is 2. All right, so that just says multiply by 4 to get to the next terms. 9 times 4. Sorry, multiply by 2, because that's what we got. See real quick, that's not going to work. 9 times 2 is 18. 18 times 2 is 36. And 36 times 2 is 72. All right, and then this last example, just wanted to cover this because just like on the last term, we had arithmetic mean. Here we have geometric mean. You're doing the same thing we just did, except you always take the square root, and you know it's always plus or minus. So I guess I should have stated that on this last one too, since that was on B, since that was an even root. This technically should be plus or minus 2, and then we just assume that it's positive because these are all positive. Is that right? Yeah. Yeah, it could have been negative. Let's just make sure. If it was negative, that'd be negative, positive, negative, positive. So I guess technically on this one, I guess it could be negative 2. I think technically, you guys can check me on this, but I think technically the answer could be plus or minus 2, because I think -2 would work as well. So check. Somebody get back to me if you can tell if I'm wrong there, but I think it'd be plus or minus 2. Anyways, same thing on the last one. It's going to be plus or minus the square root of x times y. Basically, we find the mean when there's only one term in between. So there you go. So just quickly, the geometric mean is going to be right in between those two. So plus or minus the square root of 28 times 7 is 14. So geometric mean of these two is 14. And it could be positive or negative. We don't know. Okay. So I'm going to go ahead and end it there. Like I said, guys, getting close to the end here. So stay, on your grind and finish strong and reach out if you need help. And as always, I appreciate your hard work. Keep it up. And let's have a good week.